I'm going to talk about the subatomic particles, just the ones that you already know, the protons, neutrons, electrons, just the plain subatomic particles that you've probably already heard about for your whole life so far. So first we have protons. Remember, they carry a positive charge. Neutrons carry no charge. Protons and neutrons join together to form the nucleus, which is the central part of the atom. Our electrons carry a negative charge, and they circle around the nucleus in the electron cloud. Looking at the table in the bottom, we have an electron, and the symbol for electron is just an E with a little negative sign. They're located again in the electron cloud or in their orbitals. Negative charge. Their relative mass or atomic mass unit is 0. They actually are 1 out of 1,836, but that is such a small number compared to our protons and neutrons that we give them a relative mass of 0. They actually do have mass, so electrons do have mass, they just have a relative mass of 0. So if we look at the actual mass of the electron, this is scientific notation, 9.11 times 10 to the negative 28. That just means that if we were to weigh an electron on a scale in grams, it would actually be, we would move this decimal place 28 places to the left. So it would be 0.002700911 would be the mass in grams of the electron. So super small amount. When we look at protons, our symbol for them is a P with a positive. They are in the nucleus. They are positively charged. Their relative mass or in atomic mass units is 1. Their actual mass in grams is very small, but much bigger than our electron. You also notice that their mass in grams is very similar, if not exactly the same, in this case, as our neutron. Our neutron has an N with a 0. Also located in the nucleus, its charge is neutral, and it also has a relative mass of 1. The AMU for the relative mass is called our atomic mass unit, and they found that by doing 1/12 of a carbon-12 atom to make an easier measurement to relate when you're doing conversions or adding or doing the atomic mass of atoms, instead of having to use the actual mass in grams to make it more difficult. Next, we have atoms versus isotopes. Atoms are the smallest unit of matter that still retain their properties of that element. Atoms are neutral. They are not charged. Isotopes are atoms of the same element with different masses. So they are the exact same element, same number of protons, possibly the same number of electrons as long as they're not ions, but they have different numbers of neutrons. So isotopes have the same number of protons but different numbers of neutrons. That's what an isotope is. It's like different flavors of the same element. So we have like an element, you might have a strawberry snow cone and a raspberry snow cone. They're still snow cones. They're still the exact same element. So different flavors of the same element. And when we do a lab looking at isotopes, we actually use candy. So when you look at the candy, you have M&M, mini M&M, normal M&M, pretzel M&M. They're all still M&Ms. They're the same element. They just have different flavors or different numbers of neutrons in the case of the atoms. Isotopes are also neutral, meaning they do not have a charge. So their protons and electrons are going to be the same amount. Atoms with too few or too many neutrons can exist for a while, but they're going to be unstable or radioactive. So they're not going to want to stay with a ton of neutrons or too few neutrons for very long. When we're comparing isotopes, you do have a question like this on your test. When you're comparing those isotopes, they're going to always be the same element. So in this case, they're all lithium. They're the same element. They also have the same atomic number. And in your isotope symbol, the number in the bottom left is going to be your atomic number. So down here, 333, that's my atomic number. That's also equal to my number of protons, the 3's in the bottom, and my number of electrons. You can also look at the drawings. You can see there's 3 electrons around each of these and 3 p's inside the nucleus. The things that are changing is my mass number. That's the number at the top left on your isotope symbol. So I have 6, 7, and 8. What is changing is my number of neutrons. So here I have 3 neutrons, 3 protons. So 3 neutrons plus 3 protons gives me 6 for my mass number. Your mass number is just adding your protons plus your neutrons together. Down here I have 3 protons still because that is never going to change. If I change my protons, I change the element. So I'm always going to have 3 protons. So I'm just gaining 1 other neutron. So 3 protons plus 4 neutrons gives me a mass number of 7. And over here I still have 3 protons because I can't change my number of protons or I change my element. And I have 1 extra neutron again, so I have 5 neutrons. 5 plus 3 is 8, so my mass number is 8. When you talk about ions, ions are an atom or molecule that has gained in a charge of plus or minus. So they form when an atom or molecule gains or loses electrons. Cations have a positive charge. They are your positive ions. And anions have a negative charge. They are negative ions. To calculate the charge of an ion, you would just compare your protons and electrons. And if you have your charge, it is equal to your protons minus your electrons. So if I have 10 protons and 8 electrons, my charge would be a positive 2. If I had 10 protons but 12 electrons, 10 minus 12 would be a negative 2. So my charge would be a negative 2. Whenever you're writing a charge, you have to have a positive or negative sign in front of it. Whenever you see an element that would be in the place of these x's, it might have a positive. It might have a positive with a positive 1, positive 2, positive 3, any amount of positive behind it or any amount of negative behind it. Those are positives are your cations, the negative ones are your anions. The key thing to remember about ions is that it's never a loss of a proton. It's protons have to stay the same number or else you change the element. So again with the ions, the protons cannot change. Now it is the electrons being gained or lost. So if I'm gaining extra electrons, now I'm more negative because I have more of a negative, more electrons than protons. If I lose electrons, now I have more protons than electrons, so now I'd be positive. So make sure you know that it's not gaining or losing anything besides your electrons. So just your electrons. You cannot touch your protons and change those. That would change what element you have. Here's how to read on your periodic table what each of those things mean. The top number, usually it's at the top. It's a full number, not a decimal. That's your atomic number. Those are the ones that go in order as you go across the periodic table. They're equal to the number of protons as well as the electrons as long as it's not an ion. As long as it's an atom and a neutral element, it will be equal to the protons as well as equal to your electrons. The symbol is a 1 or 2 letter abbreviation derived from the element's English or Latin name. That's why sometimes it doesn't make sense if you look at like silver or gold or lead. They don't quite make sense. Like carbon, a symbol of C makes sense, but those other ones it doesn't. That's just because it goes by their Latin name and they took an abbreviation from their Latin name instead of their English name. Usually some periodic tables will have the common name of the element as well. And then your decimal place or your decimal value on there is your atomic mass, which is not the same as your mass number because your mass number is when you add your protons plus your neutrons for a specific isotope. Your atomic mass is when you take the weighted average of all of those masses, of all of the elements' isotopes. We'll talk about that when you do the Candium lab. You'll understand you're rounding the atomic mass to the nearest whole number. That yields the mass number for the most common isotope. So remember again, mass number is the sum of the protons and neutrons. So when you take the sum of the protons and neutrons for all the different isotopes, and then you take a weighted average, that's how they get their atomic mass. At this time, you should pause and go complete your world's famous table to practice using those values on there. Remember, if you want to find your neutrons, you need to do mass number minus atomic number, and that gives you neutrons because your mass number is your protons plus neutrons, and your atomic number is just your protons. So if you do your mass number, which is both, minus the protons off of it, that leaves you with your neutrons. So again, look at this symbol. Again, you have the mass number isotope symbol. You have the mass number top left, atomic number bottom left, and charge to the top right. Here's an example here. We have 36. That would be my mass number, my number of protons plus neutrons for chlorine. Atomic number is just my number of protons. If I have up here, I have a charge of -1. If it's a negative charge, it's an anion, which means it's gained an electron. So I have an extra electron. So I actually have 18 electrons. Another way I could find my number of electrons would be to do my atomic number minus my charge. So 17 minus a -1 is equal to 18. So I have 18 electrons. If I wanted to find my neutrons from this, I would do 36 minus 17. And when I do 36 minus 17, go ahead and see if you can figure it out. Hopefully when you did 36 minus 17, you got 19. So you would have 19 neutrons there because you do your mass number, which is equal to both of them, neutrons and protons, minus your atomic number, which is just equal to your protons. You should get 19 neutrons. So 17 plus 19 equals 36. When we look at the numbers again, going through these with the definition up in front, we have our atomic number that's unique for each element, and it gives elements their identity. They go in order as you go across the periodic table. Your atomic number is equal to your number of protons. If you change the number of protons, you change the atomic number, you change what element it is. The protons and the atomic number are what determine what element we have. We have our mass number, which is the whole number mass for a specific isotope. It's often written after the element name, like krypton 84. The mass number would be 84 for that krypton isotope. The mass number is equal to the number of protons plus your number of neutrons. Your atomic mass is the weighted average mass of all the naturally occurring isotopes of that element. It's what's recorded as a decimal on the periodic table. We don't have all of the mass numbers listed on the periodic table. Some of them have mass numbers instead of atomic mass because there's only one isotope, so there's no need to take a weighted average. But all the rest have the weighted average mass of all the mass numbers of the different isotopes, calculated by doing the sum of the mass of that isotope, the mass number, like krypton 84. So I'd put 84 times its percent abundance, and then dividing them all by 100. So after you add up all the masses times their abundance, then dividing by 100, you can get your average atomic mass. It is what's recorded as a decimal on the periodic table. Fun fact, the atomic mass does not go in order. So even though atomic number and they should theoretically get bigger in atomic mass as you go across left to right on the periodic table, there are a couple times when the atomic mass the smaller one actually comes first before a bigger one. So that's why the periodic table is organized by the atomic number and not the atomic mass. One last look to keep track. This might be a good thing to put onto your cheat sheet to help you remember how to calculate these. Your protons are always equal to your atomic number, no matter if it's an atom or an ion. So remember, ions are charged, atoms are neutral. Your isotopes would fit in here with your atoms because they are also neutral. So protons always equal to the atomic number, always equal to that whole number that's smaller in the box with those elements in their box on the periodic table. Your neutrons is always equal to the mass number minus your atomic number. So down here, this is my atomic mass, but if I was doing krypton 84, that would be my mass number, minus 36, which would be my atomic number. That gets me how many neutrons I have. Your electrons are what's going to change. If it is an atom and it's neutral, your electrons will be equal to the number of protons, which is equal to the atomic number. But if it is an ion, so it's gained or lost electrons, to find how many electrons you have, you would do your number of protons minus your charge. So if I have a charge of +2, I would do my protons, say I had an atomic number of 10, I would do 10 minus +2, so 10 minus 2, my number of electrons would be 8. And the way you can double check it is if you have a positive charge, you should have less electrons than protons, and if you have a negative charge, you should have more electrons than protons, because electrons are negative, and if you have more of them, you'll have a negatively charged particle. If you have fewer of them than protons, you'll have a positively charged particle.